Welcome to the Chapter 7 Quiz Number 2 Review Answer Key Explanation video. So in the first few problems, 1, 2, and 3 here, you'll see it says solve using any method. So I wrote the method that I used. Answers should come out to be the same no matter what method you used. So in number 1, I decided to cancel the y's by multiplying the bottom equation by 3. So we end up with 2x minus 3y equals 24 plus 6x plus 3y equals 24. So that would give us 8x equals 48 when we add the two equations together. Divide 48 by 8, and we know x equals 6. Then substitute the 6 back into one of our original equations. I put it into the bottom, 2x plus y equals 8. So 12 plus y equals 8. Subtract the 12, and y would equal negative 4. So our answer is 6, negative 4. In part 2, I used elimination because the x's were already opposite, so they canceled. So when I add those together, I get 8y equals 16, divide by 8, and y equals 2. Substitute the 2 in for y in one of the original equations. I put it into the top. So we end up with negative 4x plus 10 equals 2. Subtract 10 from each side and divide it by the negative 4. So x would equal 2. And then with 3, because y was already on its own, I decided to use substitution. So in the top equation, in place of y, I'm putting x minus 6. So it becomes 3x plus 4, then in parentheses, times x minus 6 equals 4. So we need to distribute the 4. So we have 3x plus 4x minus 24 equals 4. 3x plus 4x is 7x. 7x minus 24 is 4. Add the 24 to each side. 7x is 28. Divide by 7, and x equals 4. Then I can take that 4, substitute it back into the bottom equation. So y equals 4 minus 6, meaning y equals a negative 2. So no matter what method you used, you should have ended up with these same 3 answers. In our matching section, it says choose the best method for solving each system. Do not solve. So for the top one, it would be elimination because I don't have a variable on its own, and I don't have equations in y equals mx plus b. In 5, both equations are in y equals mx plus b, so the easiest approach would be graphing. And in 6, x is already on its own, x equals 3y minus 4. So because one variable is on its own, we would use substitution. Now going to the back side of the review. Number 7, they want us to write out the two equations, then solve. So 6 people are going out to dinner, so that means 6 dinners will be ordered. Some are ordering the chicken dinner for $14 and some are ordering steak for $17. The total bill was $99. So if I made X chicken dinners and Y steak dinners, I know X plus Y would equal 6 because there were 6 people. Then $14 per chicken, $17 per steak equaled $99. So 14x plus 17y equals 99. Then you could solve this with combinations, substitution, or graphing. I decided to use substitution, so I rearranged the top equation by subtracting y. So x equaled 6 minus y. So I'm putting that in place of x. Then I distribute the 14, so I end up with 84 minus 14y plus 17y equals 99, meaning 3y plus 84 is 99. Subtract 84 from each side, 3y is 15. Divide by 3, and y equals 5. Then I can put that back into the x equals 6 minus y, so x equals 6 minus 5, meaning x equals 1. So there was 1 chicken dinner sold and 5 steak dinners. Now with 8 and 9, we want to rearrange both equations into the y equals mx plus b format, but instead of an equals, we'll have the inequality. So the top equation, we'd subtract 2x from each side, and then divide everything by 3, giving us y is greater than negative 2/3 x minus 3. Bottom equation, we'd subtract the 2x and then again divide everything by 3. So we'd end up with y is less than negative 2/3 x plus 4/3. So we'll graph the top one first. So we're starting at a negative 3 for the y-intercept, so negative 3. And our slope is a negative 2/3, so down to right 3. Down to right 3. It is a dashed line because it's just greater than. With our other equation, less than negative 2/3 x plus 4/3, so we're going to start at a positive 4/3, which is roughly 1 1/3 right here. Then we're still using our slope of negative 2/3, so down 2, right 3. Down 2, right 3. Connect our points with a dashed line. So we have two parallel lines, and then we need to be greater than the orange one, less than this reddish brown one on top. So our shading would be in between the two parallel lines for our answer. With number 9, y is less than or equal to 4 would give us a horizontal solid line at 4. Y is greater than or equal to a negative 1/3 x plus 6, starting at a positive 6, following our slope at down 1, right 3. Down 1, right 3. So I have both lines that I need. For the pink line, less than or equal to 4, anything less than or equal to that line tells me I'd have to shade below the line. Then for our blue line, we could check it with the point 0, 0. Is 0 greater than or equal to 0 plus 6? Is 0 greater than or equal to 6? No, it is not. So we're going to shade away from 0, 0, which would be above the blue line. So below the pink line, above the blue, means we're shading right out here in this opening. Then our last problem on the review, writing a system of inequalities for the graph below. So the first thing I do is just figure out my equations, and then I go back to figure out the greater than, less than or equal to, or greater than or equal to signs. So if I look at my dashed equation here, it's crossing the y-intercept at a positive 3, so I know it ends in a plus 3. From this point to the next point on the line, it's up 1, right 2. So if my slope is up 1, right 2, we'd write that as a 1/2 x. So we know it's 1/2 x plus 3. With the bottom equation, it's crossing at a negative 2, so we know it ends in a minus 2. Our slope is up 1, right 2, so again, our slope is 1/2 x. So now this dashed line, because it's dashed, we know it's just greater than or less than. They shaded below the line, so y would be less than 1/2 x plus 3. On the bottom one, it's a solid line, so we know it needs the or equal to piece. And they went above the line, so y is greater than or equal to 1/2 x minus 2. So our system would be these two equations right here.